So we talked yesterday and today about total distance traveled and about displacement. I want to make sure we all notice this important position fact number 1. An object's ending position is its initial position plus its displacement. So wherever it started plus the net travel it gets done. So we're going to practice using that here for this problem. So I have a velocity function, and I'm going to use analytic methods. That means use algebra or calculus, not your calculator, for example, to find when the particle is moving to the right or the left and stopped, the particle's displacement, and if you know its initial position at time 0 is 3, can I find the particle's final position? And then total distance traveled, which I'm going to find by hand. So here we go. Let's go our whiteboard up. Oh, my important velocity fact number 1, all the way back from last semester, if velocity is positive, then motion is forward, whatever forward means in the context. So here in the case where we have a particle moving along the x-axis, we say that motion is forward when it's moving in the positive direction, so to the right. The particle is moving to the right. So I want to find out when the velocity is positive or negative, or if I want the particle to be stopped when the velocity is 0. So I'm going to make a sign chart for the velocity. So here's v of t's sign chart. What math am I going to have to do to figure this out? Well, I want to find out where the velocity is 0 so that I can use numbers in between those places to decide if velocity is positive or negative. So if I only have from time 0 to time pi over 2. So I need for 6 sine 3t to equal 0. I'm going to divide both sides of that equation by 6, and I end up with sine 3t equals 0. So this is a review of how to solve this trigonometric equation. Is it a huge topic for the AP test? It's not a huge topic, but maybe once every other year you're going to find that you have to solve an equation like this. So what I do, notice my only candidates are between 0 and pi over 2. I need to think of what t could be. So if I multiplied t by 3 and took the sign, 0 would be the result. Well, I asked myself, when do I take the sign of something and the answer is 0? Well, the sign of 0 is 0, so I could let 3t equals 0, because then the sign of 3t would be the sign of 0, and I would have a solution. So that tells me that I'm going to divide both sides by 3, and I would get t equals 0. Well, I was probably going to have to put that one on my list anyway because it's an endpoint. But now I won't try to use 0 as an input value because I know specifically the velocity at time 0 is 0. So let's put our pi over 2 in over here. That's our other endpoint. So what other angle could I find the sine of and have the result be 0? Well, that's going to be pi. The sine of pi is 0. So it could be that 3t equals pi. Because then, if I replace this 3t with pi, I'll be taking the sine of pi, which is 0. So in this case, t is pi over 3. Is there another time? So I'm going around the unit circle thinking of angles that I can take the sine of to get a result of 0. Well, sine of 0 is 0, sine of pi is 0. The next time around is sine of 2 pi. So I could say that 3t equals 2 pi. If I divide both sides by 3, I get t is 2 pi over 3. But that's past the end of the interval that I'm interested in analyzing. So now I have set I'm building my sign chart for velocity, so I'm going to need to get the rest of this out of the way. I hope you enjoyed that trip down trigonometry memory lane. So now I've got these zeros on my velocity chart. I'm going to find a value in between them to test each interval to decide if the velocity is positive or negative on that interval. So I'm going to think of an angle between 0 and pi over 3. So I might choose pi over 4. So let's find v of pi over 4. Remember, the only thing that is really important to me is knowing whether this result is going to be positive or negative. That's going to be 6 times the sine of 3 pi over 4. Let's see, the sine is like the y coordinate. So if I go to 3 pi over 4, that's into quadrant 2 where the y's are still positive. So the sine of 3 pi over 4 is positive square root of 2 over 2. I'm going to multiply that by 6. What's really important is that the result is positive. You could check, but I'm going to promise you that if I pick a number between pi over 3 and pi over 2, the sign SIGN of sine of 3 pi has to change when I let t pass through pi over 3. So this is going to be negative. So I have my velocity sine chart, and I'm going to make my answer for letter A. So, okay, apparently I have a hard time at typing the words that the particle is. But the particle is stopped at time t equals pi over 3 and t equals 0 because the velocity is 0. The particle is moving right on the time interval 0 to pi over 3 because velocity is positive on that time interval. And the particle is moving left on pi over 3 to pi over 2 because the velocity is negative. The particle's displacement for the given time interval. So I'm going to move this. We call it displacement is found by integrating the velocity. So on the time interval 0 to pi over 2, if I want the displacement, I'm going to integrate from 0 to pi over 2, 6 sine 3t dt. I'm going to integrate using a u substitution. So u is 3t. du over 3 equals dt. Let's see. I'll fix up my limits. So that means my new lower limit is still going to be 0. I'm going to call that u of 0 equals 3 times 0, which is 0. And u of pi over 2 is 3 times pi over 2, which is, so u of pi over 2 is 3 pi over 2. So my new integral, it's going to be the integral from 0 to 3 pi over 2, 6 from this 6, divided by 3, for that divided by 3, sine of u du. So it's going to be 2, 6 over 3 to make 2. The antiderivative of sine is negative cosine of u. And I'm going to evaluate from 0 to 3 pi over 2. So that's 2 times the negative cosine of 3 pi over 2. Well, the cosine of 3 pi over 2 is 0. So it's going to be 2 times negative 0 minus 2 times the cosine of 0 minus 2 times the negative cosine of 0 is negative 1. So that's going to be 0 minus negative 2 to make 2. So the displacement is 2. That's a good time. If the starting position is 3, what is the ending position? Well, the starting position plus the displacement, final position, which we would call x of pi over 2, is going to be the 3 that I started with plus the 2 displacement. So final position, 3 plus 2, 5. So now it's time to find total distance traveled. If this were a calculator problem, I would type in that I wanted the integral from 0 to pi over 2 of the absolute value of 6 sine 3t dt. It's not a calculator problem. This is the place where I want you to find this total distance traveled by hand. So this means I'm going to integrate from 0 to pi over 3 v of t. And then I'm going to add the absolute value of what I get when I integrate the velocity from pi over 3 to pi over 2. Why did I split it up here? Because On the interval 0 to pi over 3, velocity is positive. So the area under the velocity curve is going to be positive. And I want to pretend that the area under the velocity curve is also going to be positive between pi over 3 and pi over 2, but it's not. Specifically, it's negative. So I'm going to find that area and then change it to its absolute value. So v of t dt. So I've already done all that work to find the antiderivative. I could, let's see, u is 3t, so u of 0 is 0, u of pi over 3 is pi, u of pi over 2 is 3 pi over 2. So I'm going to integrate from 0 to pi. That was 2 sine u du plus the absolute value of the integral from pi to 3 pi over 2, 2 sine u du. And we said that that was going to be negative 2 cosine u from 0 to pi plus the absolute value of what I get of negative 2 cosine u from pi to 3 pi over 2. So I am in the way, so I'm going to move my little picture. All right, so this is going to equal, I'm going to change colors just to kind of differentiate my work. So this is going to equal negative 2 cosine of pi is negative 2 times negative 1 minus negative 2 times the cosine of 0 is 1. I'm running out of room. I appreciate your patience with me. So just clarify, I'm going to simplify that part first. That's going to be 2 plus 2. So this part is 4 plus, I'm going to come back here, negative 2 cosine of 3 pi over 2. Well, cosine of 3 pi over 2 is 0, so that's negative 2 times 0 minus negative 2 times the cosine of pi is negative 1. So it's going to be 0 plus negative 2. This is plus negative 2. So that second part where the velocity is negative, I have an area between the velocity curve and the time axis that's negative 2. But I'm going to pretend for a second that it's positive. So that's why I'm taking the absolute value of this part. So I'm going to have 4 plus the absolute value of negative 2. The total distance traveled by the particle is 6.